Hi, my name is Vanegas, or Peter Angel Vanegas. I'm a computer science student at Florida International University, and I'll be presenting context-sensitive, template-based text generation for robotic agents. This summer, I was fortunate enough to be able to work with Dr. Reed Simmons and his graduate student, Roshni Kaushik, as a Robotic Institute Summer Scholar here at Carnegie Mellon University. For starters, it seems like we're just going to start becoming increasingly more interactive with robotic social agents. Whether it's something as simple as working with Siri on your iPhone, or maybe walking up to a robotic receptionist to ask for directions, or maybe even something really complex like working with a robotic tutor trying to teach you something new, we're just going to start becoming increasingly more social with robots. Appropriately, since we're being social with them, we expect them to be appropriately social with us. What does this mean? Well, humans have all sorts of emotions, all sorts of ways of saying things, all sorts of tones and moods that they might convey something. We expect robots to meet this human standard. And though much research today has shown that we're able to control the domain or the topic of a conversation, we aren't necessarily yet quite able to fine-tune the emotions that a robot is trying to convey without rigorously hard-coding in a set of rules. A lot of generation for text these days focuses on using statistical models and strictly statistical models to try to see and hone in on where words might occur. But this work focuses on using statistical models along with some manually curated phrases. So, what even is a templatic approach? Well, instead of trying to generate entire phrases from scratch, we instead use some pre-curated phrases which are stored in a text file. This text file might contain many phrases, all intended to be used in the same situation, and these phrases themselves might have different tags indicating that certain aspects of them might need to be changed, such as the adverbs or the adjectives, in order to fit a specific mood. The intent behind this is that a robotic agent should be able to read the environment it's in. Say, maybe somebody who it's working with is frustrated or performing particularly well on a task, then it should be able to send some tags over which state the appropriate feedback for that situation. Of course, tacking together a whole bunch of sentence fragments in and of itself isn't very impressive. So, we attempt to use sentiment analysis and word vectors in order to come up with a more novel selection process when generating these phrases. The flowchart for this is fairly simple. First, the robotic agent analyzes a human's emotions and performance, then determines what an appropriate response to the human's current state would be. The agent then sends over related tags ordered with a vague idea of what the response should look like. This is all handled outside of the scope of this project. The processor then recombines the phrases within the phrase files using this tag map that was provided, stores these phrases, and then scores them in order to meet a certain set of parameters that are provided to it. A selection is made randomly from a set of best fitting phrases that were generated. Scoring and selection are performed using two main metrics. The first is sentiment, which attempts to analyze how negative or positive a word or phrase might be. The second is word vector distance. Word vectors show the relationship between words by representing them as vectors within a vector space. Words which are more closely related appropriately have a smaller distance between them. The values that are provided by these two approaches are then normalized, and then the importance, that is, if I want to focus more on sentiment, or if I want to focus more on the relation between the words, can be weighted and appropriately chosen to the designer or dialogue writer's liking. Our results are as follows. We're currently capable of producing more novel sentences using our templatic approach, but we still lack some specificity when selecting tonally appropriate phrases. This lies in the fact that some words are not just closely related, but tend to score fairly equally when scored sentimentally as well. An example might be good and nice, which are generally very pleasant words and also very well related to each other. Additionally, we also found that changing our alpha value in order to differently prioritize either sentiment or semantic distance had an effect on which words were chosen. In this scenario, we use the word move, which in a chess game might be a response for a good move or a nice move. When our alpha value was low, we prioritized the semantic distance. This led to some words being favored pretty much always. For example, good occurred in pretty much all of the different scenarios, as it's both closely related to the word move and also just a generally positively scored word. However, some words started to appear once we started prioritizing sentiment over distance. For example, amazing started to appear once alpha became 0.5, which leads to an equal weight, and consistently occurred as we moved towards 0.75 and 1, in which case we were favoring sentiment. However, we still had scenarios where certain appropriate words still would not appear. Additional options in this list were splendid and fantastic, and despite changing the alpha value, they never appeared at all, even though we as people understand that these might be appropriate responses. For the future, we'd also like to find ways of improving our ability to score words and phrases. This might involve changing the equations that we use to create these scores, but it also might involve changing our approach. Instead of using sentiment, we might use emotion analysis to create different values. We'd also like to see this in a complete implementation with a robot, for example, one that can create body movement or have different facial expressions in order to create a more holistic experience. Additionally, we were limited by the analyzers that our Corpora were trained on. For example, VaderSim uses social media information, and Glove uses general English. However, these might not always accurately reflect the environment that they're used in. There could be a major difference if we were instead to use educational or business corpora in order to create our scores. And that marks the end of this presentation. My sincerest thanks go out to my mentors who got me up to this point, the mentors who helped me through this program, and all the faculty here who are there to support us along the way.